Hey guys, we're gonna continue with example 2. Let's see if my microphone's working. Okay. Example 2. Point P has the coordinates of x, comma, y is given. Find exact values of the 6 trigonometric functions. Now let's talk about this direction right here. Did the direction state that is point P on the unit circle? It didn't say that this point is on the unit circle, so you cannot assume that the point is on the unit circle because it didn't say. So what you need to do is sketch it out. Okay, so here we go. 1, 2, 3, 4. 1, 2, 3. Here is point P, 4, comma, -3. And I'm just gonna draw a ray, or more like a segment. Okay, so there is my segment, point P. I'm going to make a 90 degrees angle to my x-axis, okay, called the reference angle, and I'm just going to quickly sketch out this circle. Circle, circle, circle. Okay, so check out this not very perfect circle, but you get the point. So here's the triangle, because trigonometric is the study of triangles. If you check this out, what is your radius? Please don't say 4. You know it's not 4, because x is 4 units. Y, even though we're in quad 4 and the y coordinate's negative, but the distance is still positive. Okay, so this is 3, 4, and this is a special triangle from geometry, so we know the hypotenuse is 5. That means that's also your radius. So radius is 5 units. Okay. Now, if you don't remember the fact that this is 3, 4, 5, you can also do Pythagorean theorem. A squared plus b squared equals c squared. A squared, which is 4 squared, that's 16. B squared, which is -3 squared, which is 9, equals c squared. That's 25 equals c squared. Square root both sides. C equals 2, because we're talking about distance. I don't need a plus or minus. I just need a positive. So c is 5. So either way, okay, if you remember 3, 4, 5 or not, you can recall that you can still do Pythagorean theorem. So with this said, we're going to find the exact 6 trig functions. Where is my box, right? Sine of theta, cosine of theta. Let's give theta our central angle. Tangent of theta, cotangent of theta, secant of theta, and cosecant. Oops, I just wrote secant, but then I wrote, okay, since that's already cosecant, let's do this one as secant. Secant of theta. There you go. Box it up. Here we go. That's where I want to write my final answers. So, sine of theta. Sine of theta equals, as you remember, it was opposite over hypotenuse. I cannot say that is going to be, I can't just say, assume that it's just going to be the y coordinate, because this is not the unit circle, okay? Opposite, which is going to be -3, because I'm going to have, this is a distance of 3, but the coordinates of it is still going to be negative. So opposite is going to be -3 over your hypotenuse, which is 5. Or you can say y over r, which was, remember, another ratio that we had. So y is going to be -3. Radius is 5. So my answer is -3 over 5. Cosine of theta equals adjacent over hypotenuse, or if you remember, the other ratio we had was x divided by r. X is 4. Radius is still 5. Radius will always be positive because it's a distance. So my final answer for cosine of theta is 4/5. Tangent is going to be, tangent of theta is going to be opposite over adjacent. Or we can say y over x. Your y is going to be -3. X is going to be 4. So the ratio of tangent is -3 over 4. Cotangent, I'm gonna run out of space, so I'm just gonna do it over here. Cotangent of theta is going to be x divided by y, or you can just take the reciprocal of tangent, which is 4 over negative 3. But no one really writes negative on the denominator. So they either write on the top or on the sides, but never, ever, ever on the denominator because it doesn't look very good. So we can write negative 4 over 3 for cotangent. Then the next one I'm going to do is cosecant of theta, which is the reciprocal of sine. So we can write 1 over sine of theta, or we can write r over y. Your radius is 5 units. Your y value is negative 3. And again, negative on the denominator looks unattractive. So we're just going to move it on the top. So that's going to be a negative 5 over 3. Then I have last piece, which is secant of theta, is going to be the reciprocal function of cosine, which is really r over x. Your radius is 5. X is a positive 4. So therefore, my answer is 5 over 4. Now, check out the negatives, okay? This is in quad 4, so anything that's involving the y-coordinate must have a negative in front of it, or on the top. If this same point was in quad 1, then everything is going to be positive. So this is why negative is so important. You can't just say, oh, I forgot it, and think that you're going to get partial credit. You're not going to get partial credit for missing a negative in trig, all right? All right, so that is very similar to the to when we have a point that's on the unit circle. If it's on the unit circle, then we have the radius as 1 right away, so we don't have to find the radius. But if it doesn't say that if it doesn't say about if it doesn't mention a unit circle, then you just have to find the radius. Okay, do not assume. All right, example 3. Find the exact value. Okay, I just want to tell you what this means on your in your textbook. The exact value means you may not use a calculator whatsoever. Okay. So let's talk about 3 theta. I'm sorry, not 3 theta, 3 pi, which is the radiant unit. So I'm going to draw out a full circle. Okay. A full circle, which is 1 revolution, is 2 pi. 3 pi means I have another, okay, I have another half a circle to go. So here's the point. This is where I'm going to end up. So sine of 3 pi, which is at the same dot as this one, and we're going to use a unit circle. That's why it's so important. If I were to sketch out the unit, or if I were to plot this out, would you agree that this is negative 1 comma 0? Well, sine at this particular location is going to be the same as y coordinates. Therefore, sine of 3 pi equals to 0. Cosine of a negative 270 degrees. You have to be able to sketch this out. Negative means I'm going to go clockwise. Okay, so it's going to go negative 90 degrees, negative 180 degrees, and negative 270 degrees. And we're going to use a unit circle, so I'm going to plot this point. This point is going to be x is 0. It's on the unit circle, so y is 1. So cosine is the same as the x coordinate. So for this particular location, cosine of negative 270 degrees is 0. Tangent of 3 pi over 4 radians, again, sketch it out. Okay. You need to know that a pi over 4 rad is 45 degrees. So you need to know that. So if I have 3 pi over 4, that's like 3 times pi over 4. So here's 1 pi over 4, which is a 45 degree. Here's another pi over 4, which is another 45 degrees. I have 3 of those. So here is my third. Okay. So this is what I need to do to kind of sketch out. I am in quadrant number 2. In quadrant number 2, tangent is going to be negative because tangent is y divided by x. So I just need to figure out what the coordinates are or how to get it. So first I'm going to make a reference angle. So here's a reference angle. Make it 90 degrees to the x-axis. Always 90 degrees to the x-axis. I'm just going to make this a little bit bigger, okay? So take this and draw it here. Whoop. In quadrant 2, here is my triangle. Just kind of taking this triangle and making it a lot larger. This is what we went. We went 3 pi over. This right here is 3 pi over 4. And this is the reference angle that we're going to use. So here's theta. Here's 3 pi over 4. Here's my reference angle. If this is 3 pi over 4, if I were to go another pi over 4, then that's going to give me 4 pi over 4, which is a pi, which is half a circle. So this actually, I'm not going to write theta. My reference angle, it's a pi over 4. Because I have to go another pi over 4 to get to a half revolution. Now, pi over 4, as we mentioned over here, is the same as 45 degrees. Okay, so my central angle is 45 degrees. My reference angle is 45 degrees. So with the 45 degrees, by now, hopefully you have it all memorized, that the fact what tangent of 45 degrees is. So if we are y, because we're in quadrant 2, y is going to be a positive 1. X, because we're in quadrant 2, x is going to be a negative 1. And the radius is rad 2. I don't know why I wrote rad 3, but it's supposed to be rad 2. Okay? Or you just have memorized that. That's going to be tangent of any multiple of 45 degrees is going to be either 1 or negative 1. So tangent is going to be y, which is 1, divided by x, which is negative 1. So 1 divided by negative 1, which is going to give me a negative 1. Okay. So tangent of any multiple of pi over 4, it's always going to be either 1 or negative 1, depending on what quadrant it is in. Alright, our last piece. I'm going to help you out with the sketching, but I'm going to ask you to find the solution on your own. 7 pi over 2. As you know, 2 pi equals 1 full revolution. Okay? So I'm just going to sketch it out. Here is 1 full revolution. That's 2 pi. 2 full revolutions. That's 4 pi. 3 full revolutions. That's 6 pi. But I have 7 pi, so I have another half of a revolution to go. So would you agree that this is where I'm going to end up? And if I end up here, it's exactly the same location as here. I just have to go around more revolutions. So this is the same exact coordinate as this particular problem, which is negative 1 comma 0. So secant, I'm going to help you out a little bit. I'm just going to give you a hint. Secant is the reciprocal of another trig function. Okay, so fill this in right here. What is this another trig function? And your job is to find out what the final answer is. So I'm just going to write here on your own. And then when I check your notes the next day, or the next time I'm able to check your notes, I need to see this completed as well. Now, before we wrap up, though, we have example 4 to fill out. Okay, we're going to do example 4, and then we have the table, and that's going to be the last piece for this video. Example 4. Find the exact values of the 6 trigonometric functions. All right, here we go. I'm giving you a negative 135 degrees, and guys, sketch it out. If you have no idea where this is located, draw it out. So a negative 135, I'm going to go clockwise. So here's negative 90 degrees. And I need to add another 45 degrees, okay, to have a negative 135. I'm going to use a reference angle. That's why reference angle is so important. Okay. And I'm going to form my right angle to the x-axis always. So this is to go, this is 135. I'm going to need to add how much more so I can get to 180. So it's 180 take away 135? That is my question. Hopefully you said 45. Okay, so this is a reference angle of a 45 degrees. So I'm just going to zoom in on that little sketch, and then we'll zoom back out for the rest. All right. There you go. Out of focus. Okay. So this is a reference angle of 45 degrees. And as you know, with 45 degrees, hopefully you're in quadrant number 3. So let's write sine of negative 135 degrees, cosine of a negative 135 degrees, tangent of a negative 135 degrees, cotangent of a negative 135 degrees. I'm kind of out of space, so I might do these a little bit on the back. I'm missing cosecant of a negative 135 degrees and secant of a negative 135 degrees. Just realized I didn't give you enough space at all. Okay, so here we go. I'm in quadrant number 3. X is negative 1, Y is also negative 1, and this is going to be rad 2. So the triangle 45, 45, 90. Or by now, you should be able to know sine of any 45 degrees is going to be rad 2 over 2. But I'm in quadrant number 3, so that's going to be negative. Cosine of multiples of 45 degrees is the same as sine, rad 2 over 2. But I'm in quadrant number 3, so this is also negative. Tangent, as we spoke earlier, of multiple 45 degrees is always 1. The question is it going to be negative or positive? Well, a negative y and a negative x will make this a positive tangent. Cotangent, hey, what do you get when you take the reciprocal of 1? It's also 1. Cosecant of a negative 135 degrees. All you have to do is take the reciprocal of which one? Oh, it doesn't really matter for 45 degrees because they're exactly the same. So if I were to take the reciprocal of rad 2 over 2, technically, it's still going to be negative. And technically, you could do this. Okay, but if I were to take the reciprocal or rationalize this, would you agree that I have a negative 2 rad 2 all over equals negative 2 rad 2 all over 2, which the 2 and the 2 would reduce. So I have a negative rad 2. Cosecant of a negative 135 degrees is negative. Oops. Ooh, you can't see that. You can't see any of the reducing I did. Cosecant of a negative 135 degrees is going to be negative 2. Secant of a negative 135 degrees, because again we're in quad 3, it's also negative, and it's the same as, and I keep writing rad 3, I meant rad 2. Alright, and it's the same, so it's going to be also negative rad 2. And it doesn't look like I have enough space for B, C, or D. It doesn't mean I'm not going to do it, I'm just going to have to get a blank piece of papel, so just hold them tight. Okay, so here's B. Okay, B, we have pi over 4. So now I'm going to ask you, pi over 4 radians is what degree? Pi over 4 rad is equivalent to da 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 da. Hopefully you mumble 45 degrees. Okay, so I'm going to draw a little sketch. Pi over 4 positive, so counterclockwise. Here's a ray. Because I need to make a reference angle, and the reference angles always form a 90 degrees to my x-axis, it's also a reference angle of 45, or pi over 4. In a 45, y is 1, x is 1, and hypotenuse is 2. So let's find our sine of 45 degrees, cosine of 45 degrees, and you might have to do this on the back, or just take out a blank piece of paper and then just staple it behind this. Tangent of 45 degrees, cotangent of 45 degrees, I know, cosecant of 45 degrees, secant of 45 degrees, 1, 2, 3, 4, 5, 6, alright, we got all 6, here we go. Sine of 45 degrees, remember, multiple of 45 degrees. I love it. It's in quad 1, so everything is positive. So by now, we should know that it's rad 2 over 2. Or you can say, hey, sine its opposite over hypotenuse, which is 1 over rad 2. Rationalize it, you're going to get rad 2 over 2. Cosine is the same as sine, rad 2 over 2 as well. Tangent of 45 degrees is going to be opposite over adjacent, so 1 over 1, it's 1. Cotangent is the reciprocal of tangent. What do you get when you take the reciprocal of 1? You get 1. Haha. Cosecant is the reciprocal of 1 over sine of 45 degrees. Well, let's talk about it. Sine is opposite over hypotenuse. That means is going to be, if I were to take the reciprocal, then it's hypotenuse over opposite. Hypotenuse is rad 2, opposite is 1. So, as you know, I'm going to end up with rad 2. And secant is exactly the same as cosecant for the 45 degrees because x and y are identical. I'm also going to have a rad 2. So I love 45 degrees. Okay, sine and cosine are both identical, depending on the quadrants. Cotangent and tangent are both identical, and secant and cosecant are both identical. Okay. All right, I have 2 more left, and I'm only going to do 1. So which one do you want me to do? And then you're going to have to do the other one that I don't do. So, okay, I'm going to do C, and then your job is to do D. Okay, so here we go. C. I'm asking you to find the 6 trig functions of pi over 6. And pi over 6, by now you should know that is equivalent to 30 degrees. So let's draw that out. Okay, so 30 degrees is this little piece right here, or pi over 6. I'm going to make a reference angle, which is here. Pi over 6, the reference angle is itself. Okay, so now opposite of 30 degrees, it's always, and if that's 30 degrees, then this is 60 degrees, obviously. Opposite of 30 degrees is always 1. The hypotenuse is 2. Opposite 60 degrees is rad 3. Okay, so these are the measurements. Or, by now, if you memorize the table, it's even better. So we're going to go sine of pi over 6. Oh, you know what? On this previous one, don't do what I did here. Notice how I wrote 45 degrees instead of pi over 4. Whatever the format that is originally given to you, that's the format that I want in the end. So all of these 45 should have been a pi over 4. Okay, so all of these should have been a pi over 4. My bad. Because the format I gave you in the original problem, it's in radians, and I want it back in radians. If the format is in degrees, which is in example 8, then you can write in degrees. Alright, so that's pi over 4. Alright, sine of pi over 6, here we go. Cosine of pi over 6, tangent of pi over 6, cotangent of pi over 6, cosecant of pi over 6, and secant of pi over 6. Alright, here we go. Sine is going to be opposite over hypotenuse. So opposite is 1, hypotenuse is 2, so 1/2. Cosine is going to be adjacent over hypotenuse, so that's going to be rad 3 over 2. Tangent is going to be opposite over adjacent, which is rad 3. You need to rationalize this, so multiply top and bottom by rad 3 over 3. You're going to end up with rad 3 over 3. And cotangent, it's going to be the reciprocal of tangent. Okay, so if I were to take this and flip it, I'm going to have rad 3 over 1, which is going to end up with rad 3. Cosecant is going to be the reciprocal of sine. Pi over 6. Oops, this is pi over 6. And sine is going to be opposite over hypotenuse, so it's really hypotenuse over opposite, which is 2 over 1, which is really 2. Secant is going to be 1 over cosine of pi over 6, which is really, I'm going to have a 2 over rad 3, which after you rationalize, which I'm going to do right now, I'm going to end up with 2 rad 3 all over 3. So those are my 6 trigonometric functions for these awesome angles. Alright, now for particularly D, I'm going to ask you to do this on your own. Alright? So when I check these on the next time, please have it all completed. All 6 of them. And this is the end of our notes.